Hello! In this video I want to demonstrate the Red Scientific Visual Occlusion Goggles. Here I have a pair of our goggles that we sell. These are designed to go over glasses, so they have a large kind of foam backing here. It will fit over most glasses will fit in there. And they have a comfortable and lightweight frame, as well as an elastic headband. Okay. The driver of our goggles is this controller box here, and it outputs the correct voltage to cause these lenses to go clear or opaque. We'll go ahead and plug in our occlusion goggles, and once plugged in, we get our chart, which is going to show us the open and close time for these glasses in real time. And let's go ahead and test that out. So plug in our glasses here. First thing first, once our goggles are plugged in, we can test to see if they're responding and if everything's set up correctly by clicking the open lens button. Goggles should go immediately clear. Close lens, open lens. Okay. The goggles can be configured over here with this little tab in the upper right hand corner of our graph. In this case, they're configured with the NHTSA setting. This is 1500 milliseconds open, 1500 milliseconds closed. So the glasses just cycle open, closed, and this is for standard kind of NHTSA style occlusion testing. So I'll show you what this looks like here in just a minute. Debounce time has to do with the button and how responsive the button is, and we'll talk about what the button is used for in a moment. There's a couple of other button modes. Click or hold, which change the way the button responds. If we click these buttons down here, it can change to an e-blindfold configuration, where this can be used as an electronic blindfold for evaluating how long it takes for somebody to identify items in a scene, or direct control, which allows you to control the glasses by pressing a button and the glasses open and close directly. So let's start with the NHTSA control here. Okay, so with NHTSA selected, we're going to go ahead and begin an experiment. We're in the new folder, we'll select it, and we'll run. Lenses cycle open and closed every 1500 milliseconds. And we'll hit pause. A little data come in. They show that 6,000 milliseconds of total shutter open time and somewhere in the neighborhood of 5,800 milliseconds of total shutter close time. We can see that precise number in the output file. Let's collect some more data. And as we collect data, the plot is populated. We also can add different markers to this file, including a key flag, which we can use for different experimental conditions. We can post notes, we can name our condition. I go over all of this in more detail in another video. But let's take a look at the data. Open last saved location. Here we have our video that I just recorded. And here's the data from the occlusion goggles. Okay. So easiest to understand these data inside of an Excel chart. Okay. So here we have the event ID. We'll pay special attention first to these ones that say VOG_40. Those are the data that come from our device. If we recall, we collected 2 trials worth of data. The first one had a total shutter open time of 6,000 milliseconds here under open. And I said somewhere around 5,800. Turns out it was 5,790, and that's under closed milliseconds, so 5.79 seconds. The second trial had a total shutter open time of 3 seconds and a total shutter close time of 2.205 seconds. So if you add up all the times that the shutter were open and all the times that the shutter were closed. In the end, we add a key flag to our file, and you can see that when a key flag is pressed, we get the time from that, and that it can be then associated with a particular trial. We also have these events here. The first event is always when an experiment is created. The last event is when an experiment is terminated. Then we have block start and stop time. and a block start and stop time here. Now, importantly, when we stopped the block, we hit stop on the control panel and sent a message to our controller box. Our controller box then said, trial's over, and then it sent the data back. And that's why the visual occlusion goggle data come back after that block was indicated stopped by us. We can see exactly how much time that took, which is not much. So here we said stop. This is number of seconds since 1970, January 1st, 1970, with milliseconds. Here we clicked stop the block. Here the device got the message and stopped the block, and that data came back, and it was just about 30 milliseconds later. So it's pretty fast response there. Other ways of interacting with this that are a little bit more prompt, we can use the response button here. The way that works is we can plug this response button in here to the controller box. Let's create an experiment. New folder. All right, the experiment is armed. Video are now being recorded. I don't know if you saw it, but they're saved to that file there. So I'm recording two videos, one that's pointing down at my goggles, one that's pointing at me. We're ready to start an experiment. Previously I showed you we could push start and stop through this play pause button up here. Another way of doing this is we could start the experiment here, and then we could stop the experiment with a click of a button. Okay, but that signal then it doesn't come all the way through here and push pause here, which is just one challenge of starting and stopping an experiment with a button. But I'll show you, the data still come in just the same. So we can start and stop an experiment with a button, but the UI doesn't know what's going on. Starting experiment and stopping experiment. We still get the data. You can see it over here in the plot. And the data are saved to a file. And right now we have the key flag of H pressed. We could change that for Y or whatever. Let's go ahead and end that and look at the data. Okay, so now what we can see is we have these different events, these blocks that came in where we pressed the button. And we can see then total shutter open time for each of these trials and the total shutter close time. We can also see then we created the flag of Y, we changed that, and then we pushed stop on our block, and that came in, and we ended our experiment. So a couple of different ways of interacting with this. By using the buttons on the controller box, you bypass the latency associated with communicating over this USB to the controller box, to the glasses, and it just goes directly to the controller box to control the glasses. So you're going to get a little bit more accurate timing with the button. Okay, so that's how you can use our occlusion goggles to run NHTSA-style testing. We get both an output file and a comma-separated value format, which can be easily read into Excel or your statistical analysis program if you're choosing. We also get video. Should you have a webcam plugged in, you can get video from a number of sources. More video, of course, can be more taxing, and it can create some problems with latency there. So a good webcam, depending on the power of your system, and choose a resolution that's not going to be overly taxing, and you'll have the most reliable data. Okay, you can also get, like I mentioned, key flags associated with the data, and you can name your experiment. If you have any questions, reach out. My contact information is in the app, joel@redscientific.com. Here's my personal phone number. You can send me a text or give me a call. Thank you very much.